Okay. Good afternoon, everyone. Yeah, so technically we will have to stick to WebEx. Like I said, so number of registrations is still above 100. So, I mean, if somebody wants to join, we should not rule out. That's a policy. So if it goes down below 100, then I'll certainly switch to Google Meet. Okay. So yeah, so a couple of clarifications. So in the last lecture, I made a mistake in saying that I don't have the slide for it. The number of this class hierarchy, right? So if you derive further, so the protected will stay protected always. Okay, so the protected of the grandparent will also be protected of the grandchildren. So it will be visible to grandchildren. So in the class I said it will not be visible. I am incorrect. Okay, so today is going to be kind of short lecture. So we'll be discussing at another feature of C++, that is of templates. Yeah, so let's just see a potential interface for Q. Okay, so it's not how exactly the Q is implemented in the standard template library, but nevertheless, I mean, we'll be coming to standard template library very soon. Yeah, so a possible implementation would be, so we define the class Q with the, so let's assume we are doing array implementation. So it's actually array or whatever type it's irrelevant here. I mean, whatever the data structure is, it could be linked list as well. You are asked to implement stack using linked list. Okay. So, but this is to demonstrate the necessity or usefulness of templates in C++. Okay. So let's suppose, so this is the constructor and this is the destructor. So it really does nothing because there is no dynamic memory allocation involved. The procedures would be insert, delete, or insert, remove, and so on. Okay. So typically, assuming that the queue will hold integer value, so you would declare an integer array. And since this is an array, so you would have head and tail as indices. Okay. If this was linked list, then the data, of course, will be int in the linked list structure or a class for linked list with the pointer, the next pointer. If it is double linked list, then the previous pointer too. And head and tail would be pointers, in fact. Okay. So in the end, pointers are also integers, nevertheless, but we have a separate data type for pointers in C as well as C++. So now, from a designer's perspective, you might want to have queues which also have long integers or double or float, any other data type. Okay, it's not necessarily just the basic data types. Could be a queue of class objects. Okay, or say queue of student records or any other class objects. Okay, so then one way would be you just copy paste the same code. I mean, that is what happens in C. Then what you need to do is you redefine these with whatever data type you want, float or double or any other data type. Like I said, it could be even a class object. Okay. Or you could do the following. You can use so let's not worry about it right now. So one possibility is you have hash define, let's call it as type, okay, as int. So when you want to change it, you can change it to real, I mean float or double, any other data type, okay, and then use type in place of integer here. Okay. So that has the following problem in the sense that, so even with this, you will have to have different files for different types and so on. Okay, so the code, you can use the same code, but you'll have to do copy pasting and so on. You cannot essentially rely on the same code. Okay, or there could be duplicate, I mean, in the sense that the code length could be large. You cannot use it in the same file if you use this idea. Okay, so that is one disadvantage with the current setup here. Okay, so yeah, and another thing that people usually would like to do is, I mean, so that's also part of templates where, I mean, like I think some 2 lectures before we discussed it. So many times it is advisable not to implement the methods inside the class itself. Okay, so insert. So this is basically called a template because class template in a not a very formal sense yet. Because these methods will be defined later. Okay, so that is something we have seen already. So to address these things, so C++ has an interesting feature. Okay, so I hope you understand the difficulty with this, right? You will have to have different files. So one file for one type. Okay. So the problem with this is you may not know what is the type that you need. Okay, and you may not have access to the original code. For example, I mean, if you look at the standard template library in C++, so they are built by somebody else, right? So if you want to use that, say there is an implementation of Q or there is an implementation of vector, etc., etc. There are several kinds of classes available there. But if you want to have different types of data inside them, that's going to be problematic with this setup. Okay. So this setup kind of fails because we need to change the interface for different users. Okay. So particularly if you are going to build a library and supply it to users, users are basically programmers, your users are programmers, then the problem is if the programmer wants, instead of integer, something else, right? You'll have to go and look into your code, copy paste your library, I mean the header file and the implementation. So implementation need not be changed. Okay. So but the keyword will have to be changed. So he has to define type as something else, whatever he or she likes. Okay. So to overcome this difficulty, so what is known as generic programming, in the sense that you want to build objects where this type is a kind of parameter. Okay. So this is where templates are useful. So the concept of template is you have a class template where there will be parameters which are basically types. Okay. Yeah. So this is a general setup. So somebody might want int or string or float or double or any other class, maybe a student record, whatever. Okay, a student object. So yeah, this is painful. In fact, I mean, if you have hash defined type int and hash defined type string. Okay, so yeah, so that's going to be really painful for the user. I mean, why should the user be bothered about such things, right? So instead, what we do is we have templates. Okay. So template allows the following feature. The moment you declare Q as template, all you need to do is give an additional parameter. So say Q, where you use the type as int and define the variable Q. And similarly, you say that Q, the type should be string. Okay, there is no string type in C++, but there, in the template library, there is a string class. Okay, and yeah, so this is kind of fairly useful. I mean, in such scenarios, the user need not know. Okay, oh, I have to say. So instead, there is a syntax given for declaring the object, where itself you can describe the type. Okay. And this is kind of, this can even be dynamic, but yeah, I will not talk about dynamic in the lecture, but I'll leave it as an exercise for you. Okay, so I have an exercise later on. So let's look at the syntax here about template. Okay, so the keyword is template. Within L angle and right angle, that is angled parenthesis, you declare class, or you can also use type name, and this is a type. Okay, so this type is a variable here. Okay, so when the user writes a program, this type has to be instantiated. Okay, now instead of int, you use type everywhere. Okay, so void insert, the value should be of type. The return value of remove should be of type. The array should be of type. Okay, so the head and tail does not change because we are assuming in this, I mean, array implementation. So head and tail will be integers. So this will be integers. In fact, you can even have unsigned int. Okay. So yeah, but then the I mean, there is one issue with this. I mean, we need to know how to do. So again, to improve program readability, and in fact, so for example, with the principle of header files, right? Header files will have only this data. The methods will not be really implemented in the header files. So in that case, you may have to define these methods, in this case, insert and remove elsewhere. Okay. So how do you do? We really know how to do it. I mean, we use this 4 dots operator. Okay. So void q. So this is the type. So this is the namespace inside the class q. Insert is a method where it, now there is a problem here. Okay. So this type is within the scope of this template, that is here. Okay. So the type is relevant only within here. So type is unknown here. Okay. Similarly, type is unknown here. So this program, if you write it this way, it won't really compile. Okay. So the point is, I mean, it won't know what the type means here. See, in the same class, I can have another template, right? Template class with the same parameter type. This is like a function here. Okay. So this is basically a parameter. So it's basically a family of classes. Okay. Whatever type, that's an instantiation. Okay. So, or yeah, this is like a parameterized class. Okay. So class has a parameter. Parameter is a type name. It could be multiple. You can have type 1, type 2, etc., etc. Okay. Yeah, for now, I will just focus on single. Okay. So then let's see how to overcome this, or how we can really, within the C syntax and semantics, this is a problematic thing because type is not defined. If you had defined the method here itself, you had inserted the method here itself, for the method for insert here itself, then it wouldn't have any problem. You could have used type anywhere freely. Okay. But whereas if you want to define it elsewhere, it may not be in the same file. Okay. Then there is a problem. So let's see. How do we? Okay. So, I mean, one natural thing that one would try would be this. Why don't I just write the same thing here? So template class type. Okay. Then write the code for insert here. Similarly, template class type and insert the code here again. I mean, code for remove again here. It again, see, the point is the template keyword here, it is defined in such a way that you are going to define either a class or a function. Okay. So that way, in principle, it should work, but it does not. Okay. So this is not, because the template keyword is for a different purpose there. Okay. So the way you do it is you just tell. Okay. You just tell the compiler that I'm going to instantiate Q, so with the type. So whatever, if the instantiation is of type, okay, then I can use this. So then it's well defined here. Okay. So here I'm saying that inside the template class type, I'm defining Q, but Q these should match. Okay. So this should match. So there should be a consistency, because Q as such is not well defined. Okay. So Q also comes with the type. So say with this, right? So where is it? Yeah. So this is important here. Okay. So with our template, we have to give this parameter. If I just declare Q, it will not work. It's going to give us an error. Okay. So similarly, when we define methods for the class, the same thing. I'll have to tell. So if I just say Q, it won't work. I have to tell Q type. Okay. So this is the instantiation. This instantiation should match. Okay. So then I can use type anywhere. Okay. So yeah, so one thing that we need to note is, so yeah, we didn't explicitly allow you to use template libraries, STL. Okay, so there are classes like vector as well as string. Okay, so all of the classes which are built in the C++ library, they're all templates. Okay, but you might have seen code segments somewhere in any of this, say Geeks for Geeks or whatever websites. I mean, I think that is what you usually get in Google. So you would, I mean, very likely that many of you would have referred to that. So there people use string or vector as such without really specifying the type, right? So for vector, perhaps it is needed, not very sure, but string is not necessary. But string also has, okay? So what they do is they define this default type, okay? So if you don't really have any specific type, the default will be, so you set this as default as int or default as cat, okay? So then it works fine, okay? So yeah, that is something that we need to have. I mean, we can say the default is set to int here. Then you can actually declare q without int here as such. Okay. So we'll just do one small thing here. I mean, so we'll just see our own. I mean, not exactly q, but we'll have say, yeah. So I've taken it from Rupesh. So let's suppose we want to create a group, a class called group, okay? So, but it's template, okay? So the type of elements to be stored in the group should be the type of the template, okay? Suppose we want to implement methods add and find, whatever they mean, okay? And we want to instantiate it with two different types. One is with int as well as with string. String is from the standard template library. Okay? So the possibility is this. So let's just try it. I mean, I'm just written it here. Yeah. So we are using vector here. So far we disallowed using vector or anything. So this is again from the standard template library. Okay. So let's ignore this part for the moment. Okay. So this find wrapper. I'll come to that. What it actually means. Okay. So now, so we templatize with the parameter t. Okay. So t variable, I mean, so add has a parameter of type t, find has a parameter has type t, okay. So here what we did is we, instead of using an array, we used vector of type t, okay. We call it as a group. So now the method implementation, like we have shown for the Q class. So we use the keyword template class t now, but we have to give instantiation, okay. So you have to say group should be of type t, then the procedure here. So whatever this it is, okay. So push back is an operation in vector. Because in your current assignment, you are actually implementing this, okay. So yeah, push back element which will be of type t. So similarly, find. Yeah. So this is again a procedure that we are using, that is in the standard library, okay. So find procedure, it takes to yeah, it takes the starting of the array and ending of the array, okay, and it sees if E is one of them, okay. So if it is not the group end, so yeah, I mean, let's not worry about this functionality here, okay. Yeah, I'm not very sure what to find returns, okay. So yeah. Okay, so this basically gives the first element, I mean the first location of the okay. Yeah, so what it does is if E is in the range of begin and end, okay, start and end of the vector, so it's going to return true, okay. So, and if it is not, so yeah, I'm not very sure, okay, so, okay, I'll skip that part, okay, so because I'm not very sure what find does here, okay. So this find wrapper is again a function. All it does is it takes an element E of type T and then it sees if it can be found in the vector or not. That is, it can be found in the group or not. Okay. Yeah. So this is an example. Yeah. Sorry. Instantiation. So you want to instantiate with respect to int. So you're adding elements 5, 6, 8, and 5. Okay. Now, so if you take find wrapper 5, so this will be the first element there. Okay. And so if you take find wrapper 2, it should give no, because it 2 will not be found. Okay. So if you say find wrapper 6, again it should, so what was the output here? Not yeah, so find wrapper 6 will actually find. Okay. Yeah, so the find procedure, what it does is it takes the starting and the end position. Okay, it locates the element E. Okay, so it's in fact a linear search. Okay, so it gives the end of the vector if the element is not found. Okay, so that is how it is. Sorry. Yeah. So you can, so yeah, one more thing is, so this group you can instantiate with not only int or any of the fundamental data types, you can also instantiate with any of your data types. Okay, so here it is string, or you can also have your own class name here. So if you had described a class student record, or let's say office record, I mean employee record. Okay, so you can have it of that type. So, but the only thing is, so the problem here is, so when you implement certain procedures, so here in this case find, okay, so the find is basically implemented for vectors. Okay, so if yeah, vectors, I think it also would work for arrays. Yeah, if this procedure is not well defined for the type that you have, okay, so then it's a problem. Okay, so E here should be of the same type as the group elements here, elements in the group. Okay, but yeah, so but if you have a type, say for example, instead of, yeah, in this case string, I think find supports string as well. But if you have, oh well, it won't support string, but yeah, it supports string comparison there. Okay, so that's no issue there, because string itself has overloaded operator. Okay, string equality testing, so that is fine. But if you use, say, any other, say student type or employee type, then there will be a problem here, because this procedure is not well defined. Okay, so all you need to ensure is when you instantiate, so user should know that instantiation matches with the procedures that are applied on this type. Okay, so for string it will work, because for string the comparison operation is defined. Okay, so this find will require the comparison operation. Okay, so equality testing. So many a times the comparison operation may not be comparison operations like equality or greater than or equal to, less than or equal to, or other yeah, what else do we have? Equality, inequality, that's all right. So they may not be well defined for your class. Okay, so in such cases, so for example, usage like this will land us into trouble. Okay, so here again, so 2 will succeed, 5 will succeed, but whereas 4 will not succeed, because we have 1, 2, 3, 5. Okay. Okay, maybe I'll pause for a question.
Yes, sir. Two questions, sir.
Yeah.
Sir, here, how to means like, is there any way by which we can convert the type of this class type variable to anything, string or integer?
No, what do you mean by convert?
Convert, like we are able to means like we can convert string to integer by placing integer in brackets before the variable, like that. Can we do same thing with this?
No, I didn't get exactly. What do you mean by convert? So you mean the dynamic type conversion?
With like right now we define the type of the variable as type T, capital T
Ye-
Y P.
Yes, yes,
I
yes.
want to convert this to integer. Say it like integer.
So what do you mean by conversion? I mean, that's my question. So you want a conversion dynamic or you want to instantiate with the int?
Means like a dynamic, sir, dynamically. Yeah. Like
Okay.
in some expression, I want to directly use this. Means like the place is there. The place is of required is of an integer. It will not take type, so I am placing a integer in brackets before that.
No, I get exactly what you mean. So, so for example, you want from int to string.
No, from type to int to from type to int. TYPE to int.
See, type is only inside this template, okay? So type is legitimate only, sorry, let's stick here. So type or T here. It's only in this template. It has meaning only in this template. So when you say convert this into int, you want replace this by int, or you see this is called an instantiation here, okay? So in this main here, this is an instantiation, okay? So I'm declaring a class object group with the small g of type group, but the only thing is there the internal data there or internal methods there, they had a parameter which is t. Okay, so I'm replacing it with int. So now when you say convert string to int, I mean I didn't really understand what do you mean by that?
So within the class definition only, sir, I'm asking within the class definition.
Okay.
In some places we want to convert it, some place we want to use it as it is. Like with like a user may enter a number in string format or in number format, both. So I want to handle both cases. So in that case, I am defining something in the class only. I want to define something in the class.
Then it's not clear to me how do you use template for that, right? I mean, see, I did get exactly your question. So what you wanted to have is like you want to have both string as well as integer here. That's what you're saying, right?
Yes, sir. Yes.
But yeah, so that see one way is what I'll show you in the next slide. You can have multiple parameters, but then it cannot be like for the same group you can have string as well as integer. That cannot be. But you can have multiple parameters. So this example demonstrates that. Okay, so I can have template class T1 and T2, where T1 could be some type and T2 could be some type.
Oh, okay. Anything will be valid then.
Okay.
Okay.
Then you can do, but again, so when you want to declare a vector, yeah, so that is, I mean, vector is fairly, I think, what do you say, advanced. I mean, it also allows pairs of elements and so on. So one trick is you can use this. Okay, so you can declare vector, but you can also have pairings of type 1 and type 2. So say this is int and string, then this will be a number and a string. So this will be a vector consisting of.
I got this method, sir. This is okay. And I was asking, I was asking, is there any way to typecast this type T1 to int? This is my question. Like within our class.
See, typecast, I mean, so in some method where you use, right, that you can always do. You can use the standard typecasting, okay? But C++ has some rules, certain typecasting is not allowed as such. But you can do typecast always.
On this, yeah, on this type.
Inside an expression. I mean, yeah, typecasting, whatever you can do with C, you can also do. But there are some strict type checking rules in C++. Certain types of conversions may not be allowed, that's all. Yeah.
Okay, sir, and sir, I come out a doubt in the first slide where you created a destructor. In that means there was a method insert. What is the use of that? Means like in destructor we usually define.
This is different method. Destructor is nothing. There is nothing there.
So there is destructor is empty. Okay,
yes.
okay.
Yes. Yeah.
Okay, got it. Thank you.
Okay. Yeah, so you can have multiple parameters. So you can have, say, type T1 as well as T2. So one thing is instead of class, you can also have a type name there. Okay, so type name keyword is also allowed. So most of the textbooks actually say type. So this basically says it should be a class object. But yeah, one thing I also want to point out is the fundamental data types, integer, float, double, they are also treated as class objects. Okay, so though there is no implemented procedure on them. So I mean, fundamentally, C++ treats every data type as a class. Okay, I mean, what I mean to say is like, it's not like Java. So Java, everything is a class there. Okay, you can also use this fundamental data types in an expression and so on. But in principle, they are also treated as class, equivalent to classes. Okay, so in place where you want, so this basically says this should be of class type. Okay, so T1 should be of class type, T2 should be of class type. But I can use the keyword type name as well. So I can have multiple parameters here. This also demonstrates the versatility of the vector class. We'll discuss it in the next lecture. Okay, so it allows, it can be vector of anything. Okay, so this, in the standard namespace, there is a class type called pair. So it basically gives ordered pairs. So vector of ordered pairs. This is one example. Okay. Yeah, so there are a couple of things which is not in the slide, which I also want to discuss. So this template can also be for functions. Okay, so you can also define template of. Okay, so this basically describes a template for class. Okay, so in the same way I declare a class template, I can also have template function. So for example, this is actually, so what we did here, where is it? Yeah, so this is actually a templatized function. Okay, so template, I can have an object type or multiple types, then I can define function. Okay, so these are called generic functions or function templates. Okay, so if you look at Strauss' book, it calls it as generic function templates or template functions. Both, I mean, he just says he does not distinguish between the two. Okay, so that way, so for example, if you want to have sort function, okay, sort function, you can make it to apply for integer arrays or float arrays or double arrays. Okay, but of course, if you are using STL, you don't need any of this because vector does the job of all that. Okay, vector even implements sort function and so on. But yeah, so that's again a feature which is like useful to define functions which are kind of independent of type. Okay, in the sense that it works for any type. Only thing is, if you are using comparison or any other operation, addition or whatever, that should be well defined for the object type. Okay, so if you are having type T as your own class, but you have addition operation A plus B somewhere, okay, that should be well defined for that type. So there must have been an operator overloading for that class, which defines what plus means. Otherwise, it won't work. Okay. Yeah. Yeah. So in the lecture, we only give pointers. I mean, we don't really discuss much detail as such. Okay. So this is just for giving you a pointer where to read and so on. So yeah, so my last lecture, I didn't give reference for inheritance. For inheritance, I really liked the presentation in Strauss' book. Okay, it's fairly detailed. There are 2 chapters on it. Okay, so it talks about derived classes and hierarchy of classes and so on. And for templates, so this should be 23. I'm sorry. So chapter 23 from Strauss' book, 23, and I think chapters 24, 25, 26 also talk about things related to templates, and also read about functors, which will be useful for the next assignment. I'll be discussing briefly about it. Yeah. So here there is an exercise for you. Okay. It basically demonstrates issues with this template implementations. Okay. So see, what we have seen is you can declare variables of a template class type with suitable instantiations. Okay. Now, but how do you allocate memory dynamically? So how do you really use that? Okay, that is something I want you to learn about. Okay, so in fact, it is discussed in Strauss' book, but I want you to try it out. Okay. So one thing is you have to use dynamic memory allocation using the operator new. Okay, so malloc will not really work. I mean, it's not going to be useful as such. Okay, so the task here is to design a template class matrix Of course, the class matrix is already in STL, so please don't go and look into it. Try to define on your own. Okay. Let's say you implement it as a two-dimensional array. The type of the matrix could be int, long, double, or whatever should be the parameter. It should be any user-defined type as well. Okay. So the second task is to identify and implement methods that are necessary to implement Gaussian elimination. So all of you might have seen, but if not, please read about Gaussian elimination. It does certain operations on the rows and columns. Okay. In fact, rows, it's enough say rows. Yeah, so implement matrix methods for row transformation or column transformation so that you can use it for Gaussian elimination, and then implement Gaussian elimination algorithm. You can use it for computing determinant or computing an inverse of a matrix. Yeah. So the main part is here, I want you to write a main function that prompts the user to enter a data type and matrix dimension. Then allocate the memory for matrix object of that type dynamically. Okay. So this is something that you need to know how to do. I mean, it's fairly straightforward. I mean, fairly intuitive how it is to be done. Okay. So then, yeah, write a routine which reads a matrix and then run the Gaussian elimination. Okay. So the main thing is learn about dynamic memory allocation for class templates. And how do you define pointers for class templates? Do you really need instantiation or not? So that's going to be a challenge there. Okay, so I want you to explore and see. Maybe we can discuss in the next lecture. Or if you want any of you discuss in between, just drop me an email. Okay, I can schedule a meeting. Yeah, so that is something that you can try. So in general, I would recommend reading Strauss' book, though it is fairly lengthy, but it's very, very elaborate. Okay, so it's very elaborate about this. It also talks about limitations of these templates yeah, where it will work and where it will not work. Yeah, so for example, one analogy that Strauss gives is yeah, that is usually not available in other books. Is you can just imagine this as like for every type T1, okay, or for every type T2. So you can just imagine this as a quantifier. Or if you are familiar, if you have heard of something called functional programming or lambda calculus, okay, so there is a similar parameterization, okay, where it's called this as lambda t, okay, it's basically a parameter, okay. So the t there can be instantiated to anything. In fact, surprisingly, in lambda calculus or functional programming, t can be in fact function itself, whereas here it is not the case. T has to be a data type, okay. So that is a difference that we have. Yeah. So I also invite you to read about a standard template library. We will be starting using them in the next assignment onwards when you talk about graph algorithms and more detailed graph algorithms and so on. So I have a couple of questions for those who are doing CS2810. So can you tell me what are the topics covered after DFS and sorting? So is the greedy method being taught? Has it been taught to you? Divide and conquer. So what is the example that you have been taught? Longest common subsequence, or what is it? Or quick sort, probably. Quick sort or merge sort. Max subarray. Okay, good. Max subarray. Okay. Okay. So greedy is not yet done, right? Okay. 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 So we'll have assignment in the same vein. Okay. So okay. So maximum subarray is a natural divide and conquer. So BFS has it been taught? Qs and BFS? No? Oh, okay. So Qs and BFS. So was it not in PDS? Oh, okay, okay, okay. No, I just say because some of these implementations could be re-implementations. I mean, Stack, I think you have implemented in PDS. So, and if I remember correctly, it is also C++ implementation. So this will be pretty much similar there. Okay. Yeah. Yeah. Only thing that we try to bring in here is like more of object nature. Okay. So yeah. So the nice thing about C++ is like it gives you the imperative programming style or the usual programming style, but it also allows you to think objectively, okay, according to objects. But it's not pure object oriented like unlike Java. Java is a pure object oriented language. Okay. Yeah, except the main function, you cannot really have any outlier functions there. They have to be part of some object technically. Okay, so okay, I'll stop the recording.